Any other general questions? I really wish it would be like WhatsApp and it would tell you that someone's typing. I have no idea. I just wait and hope that maybe someone's already. I can't plan, right? Hi, Abdurrahman. So we finished 4 lessons. If I'm right, this one will be the 5th. Sort of, yeah. I mean, well, today is just class 2, which means I'm just calling it classes, okay? Every day is a class, which is a 2-hour section. By lesson, I mean, they're all kind of broken up by video. They're off by simple topics, single topics. So we've done, I think, about, 4 or 5 lessons right now if you're going by video. And today it's, this 5th or 6th, 7th, 8th video. It's better you think of it in terms of how many classes we've had. And really, we've had 2 classes. This is class 2, all right? Hi, Kevin. I don't know if I remember seeing your name yesterday, so if you weren't here, hi. Zara, hello, and another Mohammed Al-Malki, nice to see you. I'm gonna get started. For anyone who's new, this will be a little bit overwhelming, but try to relax. Not everyone had their D2L shell on time. You'll just have to do a bit of catch up. But first things first, as long as you're going through the course notes, if you work your way through the course notes with the videos, you won't have missed anything. Now, there are things that I will not be able to get to in the videos and things that might not even be able to get to in the other lesson videos. And that's just the way it's going to be. You'll have to just fill in the blanks yourself. You'll have full solutions before any tests, okay? So just, is there any class before this? Yeah, this is class 2, Abdurrahman. This is, we had a class yesterday. So I've put here what you need to do, and I've changed this every day. So make sure that every time you go into D2L, you check it every time. Join the WhatsApp group chat. Most of you are on that. Bookmark the YouTube playlists. I've made a YouTube playlist for these lessons. So if you don't want to go through the content section, they're all here for you, okay? They're all there. There's also another playlist. I just showed you this, but I'll show you it again. If you go into content, I've added YouTube playlists of the classes. So the actual recordings of these classes that you will be seeing, you will be coming to. And you can see here, one of them just finished processing. So that's our yesterday's class. Let's see. And it's still low quality, but yeah, it has everything we did yesterday. So I know it's an hour and a half, but it's a full class, right? Of course, it's an hour and a half. So use that if and when you need it, or if you choose to use it. Access the course notes. That's the course notes, of course. That's what I work through. The answers are the single answer. It's not the worked solution, it's just the final answer. I will put the workings out on D2L later at a different time. The things you should have done for today, you should have already gotten to this point. We're watching videos 6, 7, and 8. If you haven't watched them, it does technically mean you're behind. It's not the end of the world right now. I'll try to catch you up. But of course, you are responsible for watching those videos. That is part of your success in this course. If you don't watch them, no one can help you except for yourself, really. So I'm looking good in YouTube. Oh yeah, working out. Get my pull-up bar. Anyway, the quarantine. I'm eating better. So anyway, and make your notes. I'm not going to go through all of this. You have to read it yourself. You'll notice if you scroll down, we had Tuesday's class to-do list, but it's only a 1-page thing. Just be careful. Make sure you watch, you go through it and watch everything that you need to watch. Do everything you need to do. Just poke around the D2L shell. I will start math in a second, but poke around the shell. Read the news feed. And go into content. Honestly, there is not that much here. If you click table of contents, everything in the course is on 1 page here. So just go through it step by step and make sure you don't miss anything. It's better you do it now and get your head wrapped around the course than to do it in a week when we've actually done 2 weeks of classes in a regular semester, and then I'll be behind, okay? So just, I'm trying to give you as much advice as I can. So everything you could need are all here. All right, the last thing I'll say is that I have put a practice assignment in the Dropbox. I don't want you to freak out. This is not some crazy assignment, but I do want you to complete it. It should take you about 2 or 3 minutes. Open the PDF or open the practice assignment and get the PDF. It's just a course info sheet for you, student information sheet. I want you to fill this out, either print it and fill it out or just have a notepad, print it out there or fill it out there. Scan it as a single PDF file, PDF, not pictures, PDF, and put it back in the Dropbox. All right. The reason I'm asking you to do this is because on Sunday, you will have to do that for an actual assignment. And if you don't know how to do that, if you don't know how to use the Dropbox for the actual assignment, you will lose the marks. And so I'm giving you practice so that you all get a chance to do it without any marks involved. Okay. Does that make sense? I have yours already. Oh, you mean from last term? Yeah, I have yours, but that was for a physics course, and you're older and wiser now. So everyone should do this, okay? I'm just giving you a chance to practice before the assignment's worth something. Okay, so any last minute questions before I summarize what we did yesterday and move forward? I know some of you have voices more than just Abdurrahman here.
Nope.
So I'm going to go ahead and say everyone's good, everyone's totally relaxed, and we can start. Let's see, can I? Yeah, that's better. That's a better angle here. Okay, let's get started. What we did yesterday, I've tried to summarize the basic stuff. Essentially, a complex number is what this whole unit's about. And a complex number means, what do you do when you get the square root of -1? When you get the square root of -1, it's called j. It's no longer impossible to do. It just pops out a j term. That also means that if you had like the square root of -9, it would be 3, which is the square root of 9, but the negative pops out a j term. All right, that's our whole idea here. We obviously went a lot further than that. The power 1 of, and power 2, power 3, and power 4 of j all have different results. They all have their own thing. You should memorize what they are. Hi, Hamza. And we split them up and simplified them. The video for that is up yesterday. I'm not going to recap that today. What we did do is we graphed in rectangular form. That means if you had a number, let's just say 5 plus 2j, if you wanted to graph that, you would go over 5 and you would go up 2, because this is what we call the real axis. This is what we call the imaginary axis. And this is our real number. This is our imaginary number. And you go from start to finish, connect them with an arrow. That's our big idea here. We're going to do more of that today, so you don't need to worry too much, okay? I'm going to erase that so it's not too messy when we go back and look at it later. I went through some rules. For example, for conjugate. Conjugate means if you have a number and then you have a complex or imaginary part. Conjugate means to flip. So you'd have 3 and you'd turn it into the positive 2j. Hi, Hajar. Hi, everybody. That's what the conjugate means. You have the exact same thing, but the imaginary part changes sign. So this is a summary of yesterday. I've done all this, which is why I'm just going through it very, very quickly. There's a bit of BEDMAS notes there. Adding, subtracting, multiplying, and dividing. You'll notice that the real parts add. Let me get a better color here. The real parts, 3 and 5, add to 8. And 4 minus 7 equals -3. It works just like terms, right? So if you had 3 plus 4x plus 5 minus 7x, I don't think any of you would have any trouble with that. That's something you've been doing for literally years. That would be just 8 minus 3x. And so it works sort of the same way with complex numbers. The j term is its own thing. It's just a variable like anything else, okay? So once again, I'm going to delete that. Subtracting works a similar way. Multiplying, you open the brackets like we normally do, and dividing, we use the conjugate. But we're not going to worry about that today, okay? It's your responsibility to go back and watch those videos. Okay, so 1 second. All right, and then adding and subtracting complex numbers graphically and numerically. That's what we're going to review today, and then we're going to move on. The last thing I'll say before I actually start teaching is give you a big idea of what we're going to do today. For those of you that weren't here, we did page 2. All of these are on page 2. We did page 4, page 5, page 5, page 6, and then we're roughly about this part, okay? What we're planning on doing today is about all of this. It's until about page 17. So there's lots to still cover today. I just wanted you to know where you should be catching up, all right? So don't fall behind. This course is absolutely huge. I keep saying it. I will also note, you should be coming to this class on time. I know it's only been 10 minutes, but every 10 minutes in intersession is 20 minutes in a regular term. And this is an hour-and-a-half class that's supposed to be a 2-hour class, so it's even more condensed, all right? Just take it seriously. This is going to be one of the harder courses that you do. I want you to do well, okay? So let me just get right into it. I'll do a couple examples and then have you do a bit. On this page here, this is page 10. How many people are coming in? Hi, everyone's here. Almost everyone's here. Find the sum of 1 plus 2j and 3 plus j. Well, 1 plus 2j is right 1 and up 2. So we go over, that would be, let's see, right 1 and up 2. We'd write a vector like that. That's what it looks like. That is 1 plus 2j. This is our j-axis. We can think of the imaginary axis as our j-axis, okay? Sort of like x and y. Think of it like this is your x value, this is your y value. What am I going to get for 3 plus j? Let's just give it a purple. If I draw that, what do I have to do? Anyone have any ideas? What does the 3 mean? It means to go how many spaces left and right? It means to go right 3 right or right by 3. Same idea. And the j means we go up by 1, because technically here there's a 1 in front of that j. I guess I bored someone just left. Up by 1. So we go tip to tail, which means we start at the tip of the last vector. We go right 3, 1, 2, 3, and we go up 1. So it should look like this. And finally, to finish this off, we go from the start to the end. If you've done physics, this shouldn't be new. This should be something that you used to do before. It's called vector addition. Same thing in complex. So our final answer, we have to look at that red vector and tell me how big it is. Well, it's, to be clear, this is 4, yeah? And this is 3. So it's 4 plus 3j. 4 plus 3j. Now, you might want to check your answer. So there's a way to do that. You can do it graphically and just leave it and go home, or actually work out this part on top. Just actually figure out what that is. And that's what I'm going to do here. So we have 1 plus 3 is 4. And then we have 2 plus 2j's plus 1j is, of course, 3j's. And so you can kind of check your work that way. The numerical solution, the number or the calculation part is the same as your graphic part. So as long as they match, you know that you've done it right. It asked in the question to do it graphically. And so that means show me the graph. That's what it means. That's why it's called graphically. It's on a graph. All right. I'm going to quickly do this sum. So in the beginning, the first thing I'm going to do, I know this was done on the videos, but I wanted you to try some of these. I'm going to take this piece here. Notice this is something that should be changed. So 5 minus 2j, change it to a plus and change all the signs inside. So it should turn into a negative 2 minus j. And now we can work with this. Okay, so the first one, it needs to go right 5, down 2. 1, 2, 3, 4, 5, down 2. So our arrow should look like this. That's what the arrow should look like, okay? The next one is left 2, down 1, from where we were. So left 2, down 1. Let me get a different color. Left 2, down 1. Our vector should look like that. All right? Hopefully you're seeing what's going on. Some students take this vector and they put it here from the origin, but that's not how it works. It has to be tip to tail. And so we have to put the tip of the blue one touches the tail of the purple one. And then what am I missing? Why do I feel like I'm not finished? Join them. And we join them from start to finish, from 0, or the origin, to the end. Connect them. That's actually your final answer, which is why I'm going to write the answer now. You just look, how many did you go right? It's 3. And how many did I go up and down? It's down 3. So my final answer is 3 minus 3j. I'm going to check it with math as well, okay? So I'll put it in pencil here. 5 plus minus 2, or 5 minus 2 is 3. Negative j plus minus 1. Well, that's the same as negative 2 minus 1, which is 3j. And so the answer matches. You've done the graph. You've done the numerical. You know, hopefully, what's going on now. You can do these questions. So I've talked for maybe 20 minutes now. I haven't given you anything to do yet. I want you to try some questions. All right? I want you to try A, B, still students coming in, and D. Okay? So try A, B, and D. I'll give you 5 minutes. If you don't have, no, it's too small. If you don't have the notes, this is a good chance to go get them online. If you don't have a printer, then you should have graph paper. You know, go to a store, any store really that sells any supplies for school, and get yourself some graph paper, just as a notebook. If nothing else, get the numerical solution. You know, give me the A plus BJ form. You have a question, Hamza? Or are you just raising your hand to mess with me? Okay, cool. So I'd like you to write what your answers are in the chat, right? Like if your answer for A is 1 plus 2j, you know, just write 1 plus 2j. I'm not saying that's what it is. In fact, I'm pretty sure it's not. But I want you to try, you know, get your brain on. So I will check the numerical part. We have, this is the same as 2j minus 2 plus 3j, which is negative 2 plus 5j. So this guy doesn't look right to me. Remember, this is our real part, and these are our imaginary parts. Notice how they relate. Keep trying. So Zara, you think 8 plus j, negative 2 minus j. Which one's that for, Ibrahim? Okay. Okay, so I'm not getting negative 2 minus j, but I'm glad that you tried it. Of course, I've got my answer here. That's what I think it is. But I will show you my solution in just a minute. I'll give you about 1 more minute to get these done. Thanks, Abdul. Okay, so I'm not getting much more out of you guys. So I'll count down 5, 4, 3, 2, 1. All right, that's either a bad thing if you're not done or a good thing because you're tired of waiting for me. Let me show you how this is done. We've got two complex numbers here, 2j. 2j is the same thing as 0 plus 2j. So we just don't see the 0. So that means we don't go left or right, we just go straight up, j. Remember, if this was just a plane, we would go straight up like this. You know? 2j, 2 in the j direction. So that looks like this, 2. And then we go left 2, up 3. So left 2, up 3 looks like this. And then you connect them. So you're allowed to sort of be on top of itself because the final answer is really what matters. That means from the beginning, I went negative 2 and then up 1, 2, 3, 4, 5 times. So plus 5j, which is exactly what I got in math, in numbers. So I'm actually finished. That is my final answer. So anyone who wrote these, you weren't right, but I'm never going to tell you, it's not a bad thing to try. In fact, it is an amazing thing to try, and you have to keep trying. Don't get discouraged. If you get it wrong, try it again, 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 until you get it right. That's how anything works. It's how sports work. It's how math works. It's how physics works. It's how any subject works. It's how any learning works. Keep with it. All right, let's try the next question. So I'm going to try it numerically first, so I can check my final answer. This is 5 plus 3 is 8, and then negative j plus 2, so that's 8 plus j. So right away, your answer is excellent. I got that. And I just saw Dahia's answer. Yes, you're right. Now let's check these. Write 5 down 1. So write 5 down 1 should look like this. The next one is write 3 up 2 from where I was. 1, 2, 3, up 2 should look like this. Okay, that's my second vector. Sometimes I draw the triangle to keep myself organized, but you don't need to draw that triangle. It's just to keep my work organized. And then from start to finish, it's this. So it's 8, this distance is 8, and this distance here is 1. So it should be 8 plus 1j. So it's the same as saying 8 plus 1j, yeah? 8 plus 1j, or you know that 1j means j. So we got that. Okay, how do we feel about that? Because I'm going to do it very quickly, or very soon. And just give me a thumbs up, thumbs down. Y for yes, N for no. Sad face, happy face. It'd be nice if I had a little bit of feedback. Thanks, Yasser. Thanks, Dahia. Any little bit counts, really. It really helps me because I can pace. Okay, the next one, I'll do it very quickly. I know I asked you to do D. C can be a try for yours. We have 3 vectors. This vector, and then I guess a third vector that I'll put in orange, this one. So really what I have is j plus 2 plus j plus 3 plus 2j. And the reason I did that is the same reason I did before. It's important that we add them. It's easier. Now we can do it. We go straight up by 1. And then from there we go over 2, up 1. And then from there, we go over 3 up 2. 1, 2, 3 up 2. So like this. And you connect them start to finish. So let me see if I can do this without making a fool of myself. All right. That's not bad. So when I look at this, I see 5 to the right, and I see, oops, and I see 4 up. So Bahia, thank you. As usual, can count on you to give me some answers. 5 plus 4j, and that's because it's 5 big and 4 tall. That's where those numbers come from. Excellent. Hopefully you actually tried those. If you didn't try them, not the end of the world. You can go back and try them later, but you are responsible to be able to do all the questions, okay? If there's a particular question that we're going to skip, I will tell you very specifically. Otherwise, there's no skipping. All right, the last thing I'm going to do before I move on is just check the answer. So if I add all my numbers, I get 5 here, and j plus 2j is 5 plus 4j. So again, I've got my answers matching. Numerical and graphical answers match. Okay, now that is adding vectors. We're not going to see it again. There's no more adding vectors in this particular section. There's a little bit on it later, but this is the big idea, okay? So the next thing we're going to do is polar form. And I've got a few reference notes that I like to bring up as well. So we're doing polar form. We've already done rectangular form. Polar form is basically what we've been doing, but with a little bit of a twist. Instead of drawing on a grid, instead of going over and then up and making stuff like this, we're going to consider it from a different point of view. What I mean is rectangular form is a plus bj, and it'll give you, you go over by a, you go up by b, and then your answer would be that final answer like we just did. Polar form is a little bit different. The form is r and angle theta. It can also be written as r cos theta plus j sine theta. You'll notice here it has 2 forms. You'll get really used to them soon, okay? Don't worry, it'll become second nature soon. And really the only thing that we care about is the r and the theta. Everything else is standard. It stays the same for every single question, okay? So what do those r and theta mean is really what you should be asking yourself right now. Well, I'll help you understand that. Polar form is a way of knowing the angle between the vector and the positive axis, x, and then the length of the vector r. If you did physics, it's the magnitude and direction. It is the vector, okay? So let me break that down a little bit more. If this is our triangle, so I'll just redraw it so you can follow me. If we have some arrow, r, some magnitude r, we need to know, in order to describe it, we need to know what the angle is with respect to the positive x-axis. It's always from the positive, okay? From this place here. We know that A is like, the cat is losing its mind. You hear that? Sorry. This is A, which is going to be r cos theta. If you did physics, that's second nature to you, I hope. And then B is r sine theta. So all of these things, really what we have is A is r cos theta, B is r sine theta, r is a squared plus b squared, and that's from Pythagoras. That again should not be new. You square the legs and you get the hypotenuse. And then tan theta equals b over a. This angle, you know that tan is the opposite over the adjacent. B is the opposite, A is the adjacent. This shouldn't be news to you in terms of the math, but it should hopefully make some sense. Yeah, vectors. Okay, now let me help you. The r that you really will be finding most of the time, you can make it a little easier on yourself and just remember this. R is the square root of a squared plus b squared. And then this theta is really what we care about. Remember in the beginning here, I said that we care about r and theta. I don't really care about tan theta. I care about r theta. And so, sorry, I care about theta. So to get theta isolated, we do tan inverse. It's always b over a, okay? No exceptions. It's b over a, no matter what. So this probably seems like a lot, and it is, but I think you'll see very quickly that it's not so bad. We really only care about r and theta with polar form. And let me be as clear as possible. In polar form, r is a radius. The reason it's a radius is we can describe it. Here, look. This is the radius of some mysterious circle. Okay. It could be the radius, and the angle tells us where we are in the 360 direction. Okay, hopefully that makes a little bit of sense to you. Let's work with it. Let me make sure I haven't missed anything. A plus bj is equal to A plus bj. Okay, and we're going to see this form a lot, okay? Let me just get to it so you can see what's going on here. So in this case, it says write each in polar form. I'll do the examples just so you can see. Now, 8. We need two things. We need fancy circles. 1, we need r, and 2, we need theta. Okay? 8, if we go back to what we just did, which is drawing these vectors, 8 looks like this. Right? If it's just the real number 8, it has no imaginary part, so there is no up and down. It's just 8. So what is the radius for this vector or this complex number? How big is it?
You just put 8.
It's just 8. That's the size. It's just the size of the vector. We don't have an angle to worry about, so it is what it is. The angle, again, we're measuring from the positive x-axis. If it's on the positive x, the angle is 0. So theta is just 0 degrees. We've fully described it. We can do our polar form. Remember, polar form is our angle theta. And so we just put our r in, we put a angle sign, and you'll put 0. You don't always need to put that 0, but for now I want you to put it there so you get an idea for what we're doing. There are two ways to write this. Oops, these should be zeros. So my pen is fighting me. And now these are both exactly the same answer, just written in two different ways. And you'll notice the only things that change, we have r in both of these answers, and we have theta in both of these answers. Probably should have put a theta there. Okay? Hopefully that makes a bit of sense. We'll do more examples, of course, but this is the basic idea behind polar form. As an aside here, I guess I'll keep that there. What would happen if you multiplied this back out? Okay, let's just say as a little dream sequence over here, we had 8 cos 0 and we wanted to multiply those. Well, 8 times cosine of 0, if you multiply it, is 8. 8 sine of 0. If you multiply that in your calculator, 8 sine 0, it gives 0. So really it's 8 plus 0, or 8. Well, why do I care about that? It's because this 8 is the same as our question. So our answer, we can kind of go backwards, multiply it back out, we'll get the original question back. All right? You don't need to do that check. I just wanted you to show you that that's something that happens. All right, how do we feel about this so far? Are there any questions for this polar form stuff?
No.
Okay, let me accelerate a little bit. Second question. It's 3j, that means straight up. That's 3j. I don't even need to write the amounts on them. I'm just drawing a little tiny sketch, and you should do the same. Now that it's up, I should probably say that there's also a angle. So it should be 90 degrees. The GIA says that it's 3 and 90, and I'm inclined to agree with you. The reason is R is clearly 3, because this is 3 in the J direction. It's the whole vector. And then angle is the tan inverse. Well, I don't need the tan inverse of anything, actually. The angle, you can see that it's 90. So just take it directly. So it's 3 angle 90, because it's 3 90 degrees up, or 3 outside of cosine of 90 plus J sine of 90. Okay, and that's the final answer again. That's it. So C is where sort of the interesting stuff starts happening. What I mean by interesting is that you have to deal with the actual tan and you have to deal with the R squared. But hopefully you'll see that it's not actually as much work as it might sound. So I'm going to draw a sketch for C. Again, I know this was done in the video, but I also know it's early in the course. A lot of you haven't covered all the videos yet. I'm going to expect you to do the videos, okay, normally. Anyway, this is right 3 down 2, so it looks like this. Our angle will be all the way around. So it's close to 360, somewhere between 270 and 360. What is our R? It's not 3. It's not 2. It's some sort of mix between 3 and 2. It's almost like if we had this side and we had this side, we could do Pythagoras to get R, which we can. So it's 3 squared plus 2 squared. If you forget y, it's plus b squared. Right, our rule. R is this, and it's 5, yeah. Wait, is it 5? It's root 13. I don't know if you said 5 or not. Oh, 3.61, right. So root 13 is the same as 3.61. You can keep the decimal or you can keep the root. It doesn't really matter to me. It's better for now that you keep the root, but whatever is best for you, okay? Now the angle. I know that the angle is the inverse tan of B over A. If you're forgetting what B is and what A are, B is the imaginary piece and A is the real piece, the part that doesn't have the J attached. So this is tan of 3 and inverse of 2 or negative 2 over 3. I'm going to go ahead and just say, for this particular case, ignore the negative. It will make your life easier later, okay? So tan inverse, 2 over 3. That's 33.7. Now, the reason, by the way, we're not done, okay? The reason I'm telling you to ignore the negative here is because we need to think about quadrants when we do this question. What I mean by that is, hopefully you remember that when you deal with angles, I don't know if you've learned this or not, when you deal with angles, there's 4 quadrants. 1, 2, 3, 4. There are some rules you need to know about the quadrants, which I'll just put to the side here, okay? I'm gonna just draw you a little picture. There are sort of 4 possibilities that can happen here. There's things called reference angles. This angle, this angle, this angle, and this angle. And I'm going to try to keep it as quick as I can. I'll just give you the basic rules. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Look at my sketch, okay? My sketch right now came out to be quadrant 4. Just one second. Sound like there's a zombie at my door. Is my cat trying to get in? My angle right now is in quadrant 4, okay? The rules for quadrants if you have an angle in quadrant 1, your actual angle you're looking for will just be the reference angle that your calculator gives you. Whatever your calculator pops out is what your reference angle is, okay? If your angle is in quadrant 2, let me move this over. If your angle is in quadrant 2, you might already know this. Your angle needs to be 180 minus the reference angle. If your angle is in quadrant 3, your actual angle, needs to be 180 plus the reference angle. In quadrant 4, it's 360 minus the reference angle, yes. 360 minus our reference angle. The reason for this is because what your calculator gives are just these angles here, but what we want are the angle or this angle, which is of course this subtracted from 180, or this angle, or this angle, okay? I'm not going to keep those there, but that's the idea. Anyway, long story short, you should remember these rules. For now, just take them as they are. You just need to know the quadrant, and then you can use the rule, okay? So for example, this right here was in quadrant 4. And so my angle, let me make some space here. The angle is quadrant 4, 360 minus that. I need to make my writing smaller, sorry. And then that is, what do you say, 326.3. That's fine by me. So let me make this a little smaller. By the magic of technology, I have the option to make it a little smaller. Okay, and then we'll move this over here. Sorry, it got a little out of hand there. I ran out of space a little bit. But in summary, we need r, we need theta. I got r by using Pythagoras. I got theta by using tan. But the reason that this theta doesn't work for me is because it's in quadrant 4. And so with quadrant 4, you take that angle, take it away from 360. All right, let's give our final answer. Our final answer is root 3, angle 326.3. And you could write out the full form, which I'm actually going to do. All right, that's my final answer there. Sorry, I ran out of space a little bit. I write a little bit big. Okay, so is there anything specific that I can review for that? Because that's a skill that's going to come up again and again and again and again and again. I think everyone's off doing something else. Okay, I bored you all to death. I'm sorry. So I want you to try, let's see, what are some interesting ones? Maybe A, B, and D. All right, just take 5 minutes maximum and try those questions. I'll write the sketches for you to get you started. Once again, if you get an answer and you want to share it, I'd like you to do that. That's exactly right. R is just the size of the vector. And the angle here is 180. You should write them both out because we're going to need them very soon. You're going to need to know that both of these answers are correct. It's a good idea to write them out. Does anyone else have an answer? All right, so I've written down everything you need for the first two. Try to get an answer for D. D is the trickiest one. Okay, so of course all these videos are online if you need them. First things first, which quadrant is our angle in? Hamza, Abdurrahman, Tala, Abdul Ali, Hajar, Ibrahim, Kevin, Mohammed, Salah, Zara, Mohammed.
Yes,
I know
yes, yes.
I know you're out there, and I know you all have good brains because you wouldn't even be in this course if you didn't. I know you can do this. I have no problem whatsoever with the here answering everything, but I would prefer that we had a mix because it's more interesting that way. I mean, you got to think of it from my point of view. I'm just talking into the darkness, so at least give it a try. I'm not gonna make fun of you. I'm not gonna put you down. I'm just doing it so that we can all work together. Okay? I guess something happened in my kitchen. Yes, it's quadrant 3. Okay, so let's work on this. R is square root of a squared plus b squared. Let's not even write the a and b. Let's just go straight to it. That's 4 squared plus 1 squared, which is 4 squared plus 1 squared. Got my calculator here. That's root 17. If you don't have your calculator, definitely pick one up.
4.1.
4.1. Yeah, you can change it to 4.1 if you want, or 4.12. For now, it's best to keep it as a root, but I would accept both. Okay, you can do either one. Our theta is always tan of b over a, and so this is tan of 1 over 4. I'm ignoring the signs. It's a little easier this way. That's 1 over 4. Tan inverse of 1 over 4 is 14. But it's in quadrant 4. So you should go back and
Minus
look at
250.
Yeah, it's 180 plus 14. Wait, what did you say?
Minus 270.
Minus 270. We don't want to minus because we want to go from the positive x to this angle. That's definitely something between 180 and 270.
Okay.
We're going to take, we need to take this 180 turn and we add our angle to it. So if you look back in what I wrote, quadrant 3, 180 plus the angle your calculator gives you.
I got it.
Okay. So 180 plus the angle the calculator gives you. Of course, it's 180 plus this guy here. And that would be 194. With some change. Maybe it's 194 and a decimal, but it's basically it. So we've got r and we've got theta. So that's all we need. Root 17 cosine 194 plus j sine 194. Or, of course, if you want to write the short version, that's okay too for now. Angle 194. That's our answer. Okay, thanks, guys. I appreciate it. Zara answered. Ibrahim answered. Bahia answered. Ibrahim, thank you. And Abdo. So I appreciate it. You don't know how hard this is. So it's nice to hear that there's humans on the other line. Okay. Hopefully that makes some sort of sense. We're going to move right on to the next topic. We've got a bit more to cover, of course. We've got this to cover, and multiplying and dividing to cover. And then I think it looks like more than it is. And then some exponential stuff. So it won't take as long as it might look, because a lot of this is covered already. So writing things in rectangular form. The videos are already done on this. So again, I know you didn't watch the videos, but watch the videos. I'm just doing a little extra practice. How to write in rectangular form. Really, this question is, another way of saying it is polar to rectangular is what we're doing. We're converting it from one form to another. What you need to do is you take the number, multiply it by cosine. You expand or open the brackets. So 160 times cosine of 150, and then you take 160 times sine of 150. That'll give you polar form, or sorry, that'll give you rectangular form. He is saying A is r cos theta, which is exactly true. Because you'll see here, this is 160 cosine of 150, which is exactly r cos theta. And then for the second term, we have 160 sine 150, or j, you can put the j kind of wherever you want. That is our A, and this is our B, our sine theta. Okay, it all connects together. There's many, many ways to look at this. I'm trying to give you the most simple way. So you can actually go directly from this step to the end. And what you should get is, I did this ahead of time, I think. Maybe I didn't. No, so I'll work it out. 160 cosine 150 is negative 80 root 3. That's a little bit ugly. So let's just say negative 138.6. And then let me show you something. Some students don't do the most efficient way of doing things. So on your calculator, hopefully you have a Casio or similar. First of all, you're going to want to put in 160 cosine 150. Okay, I'm a little slow because I only have my touchpad right now. I'm getting negative 80 root 3. That's a little bit, you can keep it or change it to a decimal. I'm going to choose to change it to a decimal. That's 138.6. Negative 138.6. So I wrote that out here, of course. My point that I wanted to make was, instead of putting the whole number in again, you're only going to change this by sign. So just back it up a little bit, put a sign in, and then you don't need to worry about changing it, okay? It's just a basic little skill, a little trick if you want to use it. So just delete what you don't need instead of deleting everything. So it should be plus 80. So at the end of the day, we have plus 80j. And what you'll notice is this is our A value, and this is our B value. Okay? That's the basic idea. So I'd like you to take a second, if you haven't already, and try to do B. Negative 200, let's see.
Negative 200.3 plus 92.85.
Okay, so we're getting a 0.3 there and a 0.85. That looks exactly the same. You've said the same thing. Dahlia said that and you said that. So that should be enough time to get these. Literally all you're doing is multiplying these together and multiplying this. So it really shouldn't take more than
Negative.
10 seconds, right? So we go ahead and I'll write the answer. You're both right. And that's it. That's all there is to it. Thanks, Ali. I'm glad that you got the same answer. Excellent. So I'm going to move on to the next question. This is polar form. You can
Or
kind of...
if you have to change the sign to positive for the minus 92.
Let me double... I didn't work it out. I just kind of took you as a... I trusted you. I trusted
And
you.
add 200.3.
Yes. Right. So it's... Let me see.
I told you. It's positive, you didn't believe me.
Did you say positive? Sorry, I was
No,
looking...
I did recheck it on the chats. I said
I took your chat answer. Yeah, okay. It's fine. Don't worry. Not a big deal. So that looks good. And again, if you want to put in the decimals, it's best that you keep at least one decimal to be specific and as precise as you can. But, don't take, this is the full answer. Don't give me that. No one wants to read 10 decimals. So just keep it reasonable. 1 or 2 decimals, 3 sig figs, 4 sig figs, you're fine. Okay, so now that we've gotten through that drama, this question, it's good to, at least in the back of your mind, think of it in the other form. 92.9, yeah. Which is you put the r in front and change it to the cosine form so that you can see exactly what's going on here. Now, you don't need to do that every time because, well, you'd kind of waste time. But at least once you get used to this, you can get it in the back of your head, okay? And then we're going to do our regular multiply by these two things. And we'll get our answer. So I don't know, should I trust you? I trust you this time? I've lost a bit of trust here. Not really. I'll just see what I got. I think 6.96 plus 86.1 or 14. Jay, how do we feel about that? Yes, yes. Maybe, maybe not, maybe, maybe not. -7, yeah. Okay, so if you rounded it to one decimal place, it'd be 7.0. If you rounded it to one decimal place, sorry, one decimal place is 7.0, two decimal places is 6.96. Same thing. So I had a question in my other class, and I was asked, what about on a test or an assignment? Is the decimal place going to matter? And essentially, no. As long as you're close enough and you haven't made any fundamental mistakes, it's not a big issue. For example, you might give one decimal place and my answer key has two decimal places. Whatever. As long as you've rounded it okay and nothing else is wrong, you're not going to lose any marks for that because it's arbitrary. I could keep 100 decimals if I wanted. I had to stop it somewhere. So just be careful. You're saying 3 sig figs? As a general rule, we could probably say that. It's probably better to say that if your number has decimals, keep at least one decimal. Okay? It's less about sig figs and more about just make sure you don't get an answer that's too far rounded. All right, so if you tried D, you can write the answer directly. It's just 4629 times cosine of this angle, which gives you -4624. And then it's R times sine of this angle, which if you work that out should be 197.1 J. All right. If you wanted to, of course, you could work out the full polar form first and then go from there. So I'll just put that down just so you know there's more than one way to do this. All good? That's it for that topic, actually. Well, at least this particular version of the topic. How do we feel about it? I know it's 10 to 5. It was the same thing on campus. This is the most difficult time to stay focused, for me anyway, because it's late in the day, haven't eaten in a really, really long time. I'm just thinking about food. I've been up since 5 o'clock. So I get it. I get it. It's not easy to do this and stay focused, but I'm just doing my best to stay energetic for you, even if you're there just like scrolling, feeling like you just want to go to sleep. Some of you probably are asleep. I get it. I was a student. I've done online courses. I get it. But unfortunately, this course waits for no one. You just got to keep going. And so I'm going to keep going and try to make it as seamless as possible for you. Okay? So wake up! That's kind of what I'm trying to say. Should probably take that advice as well. Okay, so we have here, give the rectangular form and the polar form for the following complex numbers. Well, rectangular form is generally very straightforward. I mean, we'll look at this. I can see that this is a 3. So A is 3. I can see that we have a 5. So B is 5. And so writing the rectangular form is very simple. It's just 3 plus 5j. All right, the rectangular form is finished. Now, polar form, of course, has a little bit more work to do, but not much. We just square the A's and B's and then do the tan thing to get the angle. So our polar form, R is square root of 3 squared plus 5 squared. So R is whatever that is. What's that? Root of 3 squared plus 5 squared. That's root 34. I'm going to go ahead and keep it as that. It's actually easier than making it a decimal. So if your calculator does it, keep that. And then I'm going to kind of travel over here to give myself some space and do the angle. The angle is the tan inverse of B over A. Well, we have B and A. It's 3 and 5. So 5 over 3. Tan inverse of 5 over 3. What is that? 5 over 3. 5 over 3. 59.0. Or just 59. So, what quadrant is this in? Do I have to do any of my fancy 180, 360 additions or subtractions? No, we don't. Because, yeah, exactly. Like you said, this is quadrant 1. So the angle is just, it is what it says on the box. You know, it is what it is. So we haven't finished the answer. Our rectangular form I wrote here, that's one answer. Our polar form, we actually have to write it out. So it's root 34, angle 59. So that's our shortest version. If I don't ask you for a specific form, you might as well use that for polar form because it's the shorter one. It's easier to write on the paper. F, I'm actually not going to do. I'd like you to do it for homework, if you're going to do it at all, because it's the same idea, okay? And I need to save some time. So we're going to move on to some multiplying and dividing. Is there anything on your mind about anything that you want to mention besides talking about food or anything else?
I need you to wait for a second. I need to read this.
Okay. No problem. That's my biggest, one of my biggest problems with the online format is normally on a whiteboard, you know, in class in CNAQ, I'd have my 3 whiteboards. And I could write something on this whiteboard and leave it there for 2 hours and be like, hey, remember that? And write something over there and be like, hey, remember that? But now I don't really have that choice, you know? So I wish I did. The best I can do is just, yeah. Oh, Ali says take a picture. Ali, you're a flipping genius. You should have just taken a picture. But yeah. Anyway, I like to wait if I can, but I can't wait too long. So
I'm done.
I'm going to move on. Yeah. So for some reason, this next topic takes almost a full page to explain it in the book, but it doesn't need that. What it's saying is if you have two different complex numbers in polar form, the r's multiply. If you're multiplying, the r's multiply and the angles add. Let me show you what I mean. The r values are multiplied and the angles are added together. So when we multiply complex numbers, we multiply the r values, but we add the angles. When we divide complex numbers, the r values are divided and the angles are subtracted. So that's for division, okay? And then you have one over the other. What I normally say is r's multiply and thetas add. R's divide. I'll write this again later, and thetas subtract. So just take that as it is for now. You'll see what I mean in a second. It's just a rule that works for complex numbers. So I'll go right to the practice section because those examples were done in the videos. What I mean is, we take a look at this. This problem is one big complex number and another big complex number, and they're touching, so they're multiplying. All we need to do is look at the r terms and multiply them. So that's 24, 3 times 8. 3 times 8 is 24. And then our angles are 115 and 96. So really what we have is 115 plus 96, and that'll be our final answer. Whatever that is. 115 plus 96 is 211. So it's 24. Sorry, just like my mind just wandered off somewhere in space. 24 cosine 211 plus j sine 211. What you should notice here is this is 3 times 8. 211 is 115 plus 96. That's all there is really to it. Okay? Seriously, someone just got here? Try B. Remember that because it's multiply, r is multiply. I can make this smaller. R is multiply. Thetas add. Take 10 seconds and do it.
R is 19.5.
Sounds right to me. Oops.
Theta 250.
19.5 and theta is 250. Yeah. Again, if you're wondering why, it's 3.2 times 6.1 for the r. And for the theta, it's 35 plus 215. That's all we're doing here.
35, not 33. I'm watching you.
I'm watching you. Yes, you in there. All right. No, I appreciate it. Like I said, this is not my time. This is the worst time of day for me. I get more energy later after supper or in the evening. You got the worst version of myself. I'm sorry. Okay, let's try C. Same ideas. If it's division here, the r's will divide, but the thetas will subtract.
R is 3.
3, and then what's our angle? It's 310 minus 105, right? 310 minus 105 is 205. That's it. That's the whole thing. The only thing I'll say is that the question was given in a different form, and sometimes they want you to give it back in the form that they gave it to you. And so I'm going to write the other answer as well. Cos, oops,
I
205.
have one question.
Yeah, what's your question?
Why when you use the first form, you just chose the cosine, you didn't choose the sine? No, they are the same. Okay, sorry.
So this is this.
I got it.
Yeah, it gets, sometimes the ideas get jumbled in your head. I get it. So that's all there is to it. And D, I'm just going to go ahead and do it while I'm doing this. It's 4 divided by 8, which is 1/2. Oh, yeah. Yeah, do my work for me. Ghosts of math past. I like this. Whoa. Oh, God. What happened? Are you okay? Everything all right? What was that? Whoever it was, you can try again. 240.
That's me.
240 with the angle, right? So 280 minus 60, 240 degrees. So 4,
Hamza, shut up.
a half is 0.5. It's okay. I mean, I can see who's annotating. It's not a big deal.
Sir, how did you get 240? I think it's 220 if you minus them.
Yeah, this is what happens when you trust in the
Yeah, when you
student.
trust them.
It's okay. Again, I know I make a lot of fun, but it would be a lot more boring if I wouldn't try to do anything. Okay, so please don't be afraid to annotate and have some fun. I mean, math, especially some topics, they're just boring as watching paint dry. So at least we can have the social interaction, right? I'm sure we all need it. Anyway, this is the final answer here. Either one of these are okay. And thank you, Gia, for jumping in here. So we'll just move right on because that was a basic, very, very simple topic, really. Here it says, in order to add and subtract complex numbers, they must be in rectangular. So what that means is, for example, this here is polar form. This question is asking us to add it, but they're
Sir, your
both in,
audio is glitching.
really?
I can't hear you.
You can hear me now, right?
With echo.
Hello? Okay. All right. Sorry. I don't know what happened, but I think you can hear me now, right?
Yes, we do.
I probably should have paused the recording, but whatever. Okay, let's get back to what I was doing. So my whole point is that this is in polar form. You can't add them unless it's in rectangular form. So if you did physics, you'll know that you couldn't add vectors as is. You had to break it into components. That's kind of the same idea as here. Rectangular form is our components. So break it into components first as rectangular form and then add it up, okay? The trick here is that it says do the operation and write the final answer in the same form as the question. So we need to go back when we're done. Let me show you what this looks like. So first of all, this is in polar form. We need it in rectangular form. Do you remember how to do that? You take the r cos theta and r sine theta. So we'll just go ahead. I'll write that out. I'm not going to take it every single step one at a time. I'm just going to write it out because this is actually done in the videos. I'm just going to write out the equivalent form in rectangular form. Okay. So this first one here, that's this guy. If you do, change the form, and then we have our other form. Now we can add them very, very easily. You just add the real parts and then add the imaginary parts together. So what you get is 0.30 plus 1.70j. And then you convert that back into polar form. So here you're saying it's 173 angle 80. I'm inclined to agree with you. Let's see, r is a squared plus b squared, and we square rooted, which is 1.73. The theta is tan inverse of b over a, which is going to be 80, and it's in quadrant 1, so we don't need to worry about anything. So it looks to me like you are exactly right. All right. So I had to expedite the process a little. Hopefully I didn't lose anybody. But that question uses just a little bit of every skill we've kind of done already. It looks a little scary in here now. I've turned off the light to try and fix a problem. Okay, so that's what you do. The other question, all you need to do is a subtraction, same idea. And C and D are a review of what we did earlier. We actually did questions like that yesterday. So for those of you that were here, you should recognize that. For those of you that weren't here, maybe you don't recognize them. All right, so what I'll do is I'll just quickly do these questions as a review. Because even if you were here yesterday, it might be helpful to see this again. So what we need to do, the question said perform the indicated operation and give the form back that you found it in. So multiply, 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 multiply. What this gives us is 15 minus 36j plus 20j minus, well, 4 times negative 12 is actually minus 48. I'll just write it, minus 48j squared. But j squared is negative 1. So what it does is it changes the sign of whatever numbers it's touching. So we can change that to a positive, and we can kind of just pretend that wasn't there, okay? It's a faster way than showing all the work. Let's see, we've got 15 plus 48, which is definitely, wait a second. Am I in the examples? I meant to be in the practice. That's okay. 63 minus 16j is what we end up getting here. 36 minus 20. All right, so perfect. Here you got it right again. Hopefully everyone else, you're at least giving it a shot or keeping your brain on, because there's so much in this course. It's just, this is not the hardest. These are the easy topics in the course. So this is where you want to get a lot of marks up front to feel, better about yourself. Okay, so that was a multiplication question, which usually involves 2 brackets. Our next question is division, which again, yesterday, do you remember there's like one word you need to think about. You already got it. You beat me to it. Same person who answered yesterday too, Abdul Rahman. You just, very consistent. Use the conjugate.
I was waiting for you to ask.
I know, yeah, I'm too predictable. This is what happens when you have me for 2 courses. You know all my patterns. So here we go. We multiply on top and bottom by a conjugate of this guy. So 3, 7j, 3, 7j, but change it to a plus. That's all that conjugate means, change sign. All right? We multiply, 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 which I'll write out. Actually, the video has it. Yeah, I'll just write it. 90 plus 210j plus 120j plus or minus 280. Again, this minus is because of a special property of the j. On the bottom, we have 9. We have positive 21j. We have minus 21j. And then finally, we have positive 49. Which again, special thing happening because of the j squared. So what does the conjugate do? Can someone tell me what it does? What is the whole reason for using the conjugate in the first place?
Take
Change
the
the
J.
sign.
Okay.
Can you say that again? Was it the here?
Yeah, you just change the sign.
But what's the reason for using it?
To take off the J from the.
To rationalize the denominator.
Yeah, so
Make sure there's no j's, yeah, like Abdu said.
that's basically the idea. You are rationalizing it in a way. Rationalizing is something we usually associate with square roots. It's the same basic idea. When we had rationalizing, you get rid of the square root in the bottom because it's not proper. When we use the conjugate, we get rid of the j in the bottom because it's not proper. It's really, we're still getting rid of square roots in the bottom, but we're getting rid of square root of -1. Anyway, long story short, we're trying to delete the j's. So this always works. If you do it right, your j will disappear from the bottom. That's the whole reason we use it in the first place. So that should give us, I think it simplifies to this. I did this ahead of time, so it should be 58 on bottom, which can actually simplify to -95 plus 165j over 29. But you can keep this if you want. It doesn't matter to me which form you use, it makes no difference, okay? Okay, so we've got 5 minutes left. I'm going to use that opportunity just to, let's see, the practice is there. I should have done the practice, but I'll assign this for homework. Just like everything else, everything is kind of homework. You should have already tried this. And we'll pick up from, oops, sorry, I'm getting tired. My fingers are not doing what I want them to do. That'll be class 3. I just want to use this time to, first of all, thank you all for coming, because there's a lot of students who aren't coming to the classes. There's students who are too confused to try to make the effort. I just want to thank you for actually making the effort to be here and even just coming to the Zoom class. If you stayed awake and engaged this whole time, I can't thank you enough. And I'm not like saying, oh, it's the best day ever. I'm not trying to make you feel like you're getting something for nothing or congratulating you for no reason. I'm just saying thank you for putting up with such a weird time. This is the weirdest time that I think we've ever had. It's certainly one of the weirdest times I've ever had in my entire life. And I've had a lot of weird stuff happen. So the fact that you're still here, you signed up for these courses, even though it's crazy busy, you're all inside, hopefully, you know, just thanks for being with us. That's kind of what I'm trying to say. It's a stressful time anyway. Who wants to put more stress on themselves by taking a course, or taking 3 courses, or taking 4 courses? It's for your future. And the fact that you're actually here working at this, it will benefit your future, even if it doesn't seem like it now. So anyway, thanks. That's my first thing. Second thing would be do the practice assignment. So go on D2L and actually do that practice assignment. Make sure you can do the Dropbox in the way that I want you to. Other than that, you know, just keep an eye on the D2L shell and keep up. That would be my simplest thing I could say. You have to keep up. If you leave, for example, if you wait till Sunday to study for the Sunday's assignment, even if it is open book, you won't do well. I'm here to help. I have my WhatsApp ready all the time. I've got email, I've got whatever. You just let me know if you need help and I'll help you, okay? I'm here to try and make this course as easy as it can be.
Sir, for the assignment, is it going to be from the beginning till what we finished?
Yes, it's the whole, the assignment will be on the whole unit.
The whole unit? Oh, you mean complex numbers, right?
Yeah, unit 1. Yeah. So we'll finish, actually, it looks like we have a lot of the book left, but we'll actually finish this topic tomorrow, because there's a lot of practice in there too, right? So by the end of tomorrow's class, we should be totally finished unit 1, which means you'll have all weekend to review it. So that'll be the assignment. It's a 30-minute assignment at the end of Sunday's class. The other thing I would say, the last thing is, and I mentioned this at the beginning, you can find all of the recordings either from from Tom, who's the one who records the videos, or from me, these classes, in the content section of D2L, all right? So if you click on this, this is where I've been storing our actual class videos. So you can subscribe to that if you want, and then you don't need to go through the D2L shell every time you want to watch a video. Seems a little bit crazy to me to do that. So it's just another option. They'll still be in the D2L shell, but they're on YouTube as well. Okay. I think that's about it. I'm going to go collapse. And again, thanks for coming. I'll see you again tomorrow. All right.
See you.
Peace.